All right, so let's go through some items here. Talk about where we're at. Got my books and move them over here. All right, because I'm going to be at this keyboard. I won't be jumping over as quite as easy to see you, but we've went from our hypothetical to now we're actually going to look at how do we actually start this idea of programming. And so what I'd like to do by the 9th is get everybody caught up at the end of chapter 8. And I think that's certainly possible. There's a few assignments we're going to work on. There's only 2 actually in Python. So the first assignment really comes out of looking at how do we start with our GUI. So a couple of really quick things. There's 2 different environments that Python can work in. So the first environment, when I go click on Python and I look at it, is I can work at Python on the command line, and I can work on Python in this, what we call the idle shell. And so there's advantages and disadvantages to each. We can also create a file with a .py extension, and you'll see that here pretty quickly. And that .py extension tells Windows that we're creating something in a Python language. So we're using our textbook now. And so chapter 1, if you haven't read the introduction, I encourage you to do that. And chapter 1 then starts to tell you about everything from how to install it to how to begin to look at our content. So very quickly, we can create our very first program in Python, and we can use nothing more than this command line environment here, and we can simply write print, if I can get the keyboard to work, print, and because I'm going to put my name in there, and that's a program that actually runs. So that's interesting and that's great. It doesn't work very well for longer programs, but can we use this environment? Yeah. We can actually copy and paste into it. But for most of what we're going to do, this GUI environment over here, this shell gives us some advantages. So the first assignment in chapter 7 or week 7, to make sure you've done it, there's several sets and points. Let me log in really quickly and I'll show you what we're talking about. Blackboard. So scroll down, chapter. So I know some of you are behind, and I'd like to get everybody caught up back on track so we can end on spring break, take a little bit of a break, come back and start here again. So week 7, although technically says it ends on the 2nd, I will take these assignments up to the 9th. So I give you, make sure you've done it and done the install. If you have Windows 8, there seems to be a little bit of an issue. So several of you I've advised, if you have Windows 8, to look at something like IO bits start button replacement. There's classic shell. There's several others because it doesn't necessarily show up correctly, unfortunately. So your assignment then, after you work your way through chapter 1, and when I say work, this really is a class where you have to work your way through the material, not just glance at it and read. So all these assignments and different things you can put in here, you have to actually do. So there's 5 questions. So what's the advantage of script mode? What does a script do? So after you read chapter 1, how do I save my program and run it later? How do I know what is saved is a Python program? And I'll give you the hint to that make sure that file extension is a .py. Number 3, what are comments? How are they used? How do I insert a comment? Because one of the important things, especially if you have a program that doesn't work so we can try to diagnose it, is those comments let me know what you're trying to do. So for that reason in here, they're a good idea. But the reality is they give us those skills or that ability to output what we're looking at. So the number 4 says, write and save a program that prints out your name and waits for the user to press the enter key before the program ends. Make sure you can run the program, copy and paste in your code to upload it. So in other words, I'm not making you on this particular assignment upload a .py file. The assignment for chapter 8, you will have to download or upload a .py file. So, and then I have my snarky little no assignment for 5. You can write something if you'd like to, but I encourage you to do 1 through 4. So we're going to take a look at that program piece of it and what kind of things here in just a little bit. So that's chapter 7 or week 7. And then the assignment for week 8. So there's a discussion board and an assignment. And so this one takes us a little more in depth in Python. It says we start working with strings, numbers, and how we can convert between the two. Okay. So we need to work our way through that chapter. And you're going to write a program to display the cost of a car for a car salesman. So the user has to enter the make and model and the price. The program then should add on other items such as undercoating, filing fees. Maybe you want to give them the option to add an extended warranty. So you're going to just make up prices about those kinds of things. So whatever you've went in and saw when you bought a car, all those additional fees. So where your car went from $10,000 to $14,999, those kinds of things. Then you're going to take that total, all those things, and add a tax. So the user's going to put in the percentage for a tax, whatever that tax rate in your local area is, and then display a final price, make, and model. So now what's fun about this is there isn't any right and wrong way to do this. Well, I take that back. There are some really, really, really wrong ways to do it, but if you can get this output at this point, you are probably doing it correctly. So let's take a look then at chapter 1 in our textbook and some of the things we're going to look at. So make sure you've read through. Chapter 1 talks about what is Python, why we would use Python, how to install Python. And hopefully everybody has Python installed. Python is a great language. I know we have several members of our community that are using Macs. Python can run on a Mac. It can run on everything, including a cell phone and some other things. A lot of software companies are using Python. So Google uses Python for some demonstrations. There's web browsers written in Python. So it's a pretty good language to start with. You can run it on almost anything. So on page 6 of your book, it talks about installing Python on other languages. If you have a strange computer, strange language, and the reality is even if you have a Windows machine, do you have Windows XP, Windows Vista, Windows 7, Windows 8.1? So I encourage you to kind of bookmark python.org because everything you want to know about Python is literally here. So installers, documentations, even if you want to look at jobs. So you say, why would I want to learn anything about programming? Why do I want to learn about jobs? And here, for example, are a list of some jobs. So if you want to go work in India, there's a job. Don't know anything about these. Skilled ones in, let's see, this one's in New York. This one's in Oslo, Norway. London. There's one in California. So there's tons of jobs and all different kinds of things available here. So back to assignments, week 7. Make sure we can get everybody caught back up to the same spot. So make sure you've read through. You can find out the advantages of script mode. How do I save a program? What do I know about it? All of those answers are contained in chapter 1. So on page 7, it introduces you to this GUI. It's called idle, or the Python GUI. And so you're going to look at something very similar to what you see on page 7 on our screen. So I'll move that over into the forefront here. So on page 8, it introduces us to something called the print function. So once again, we create or use an existing function. So print, P-R-I-N-T. So notice, anytime I put in those open and close parentheses, what that's saying is we're calling out some function. So we're calling a print function. In this particular case, I'm passing into this print function a value, or a string in this case. And I'm passing in William then into this print function. Notice I hit enter and William is output. So there's our first function that we're going to do. So what's the difference between a string and a number? Well, a string is that idea that it's some form of text. So I can output and notice I put this in quote marks. So even though it looks like a number, it's actually a string. So we couldn't manipulate it like it is a number at this point. And then it outputs it. So one of the worst things that you're going to find on this is the idea that misspellings, typos, when we read them, they're pretty easy. We understand what's going on. We don't have issues with it. We make that up very quickly in our mind. If I typed print with 2 T's, we'd know what I meant. The computer, though, on the other hand, isn't going to have a clue. So make sure you understand syntax, what that is. So in this mode, it may or may not be as useful because we have to type them in, run it, and then, oh, now we have to type this program again. So on page 10, it introduces you to what's called script mode. So script mode is easy to invoke. I just go to File, New File, and notice it looks very similar, except it's really almost like now our text editor. So now, let me try in here. So I'm going to put in here print. And notice it still highlights that in color. Not sure why I like typing William today. I hit enter, nothing happens because what we're doing is creating a program in that script mode so that we can then run it later. So if I click File, Save, and I'm going to click Save As just so we see what's happening. So by default, where is it going to save them? It's in that Python 3.3 folder. You may want to select a different folder. So in this case, I'm going to create a new folder on the desktop. Just so I know where it's at. Very handy if we're going to upload them then to class. And I'm going to call this one Program 1. So notice down here it saves as type. So I can save these in a couple of different types. What we want is the .py or pyw file. So I'm just going to save it as that. Save. And now that program's saved. And in fact, if I go to my desktop, I now created this folder, which I apparently saved it outside of. It's called Program 1, and it's called a Python file. And so if I've accidentally saved it as a text file, that's going to be an issue for us a little later on. This script environment then gives us a way we can create and store a program that's a little longer. So you need to make sure you know how to save a program. So all I have to do is click File, Save As. Well, how do I run a program then that I've saved? So I saved my program. It's hiding around there somewhere. Here's my shell. How do I run this program from this environment? Because notice this is just an editing window. So this Python shell then, some way I have to be able to run that program. And so if I look at pages 11 through I think it's 13, you're going to see that there's some instructions on how to run that. So for example, I can click up here on File and Open. And if I click in that folder, Program 1, Open, notice now it just opened that file for me. So I can close my extra window. How do I get this program to run? So notice if I run the module up there, there is another way that I can do this, which is an interesting method. So if I have added, when I installed this, .py as an extension, I can actually double click on the program. Now this won't, it runs and then it exits very quickly, and we'll have to work on how we can stop that. But I can actually find the file itself and just double click on it if I've installed it as that option. So a couple of different ways to work with that. White space is almost always generally free, and possibly the most important piece of the entire chapter happens on page 14. So on page 14, they introduce you to an input statement. So pretty simple, input. And because we know it's a function that we're getting from somebody else, we get something interesting. So input So I'm putting in a line of text that says, press the enter key to exit. Okay. So let's see what this does. So it says, yes, you have to save it. And notice it says William. It printed out my line here. And then it put in 2 lines of space. And that's where that /n/n came from. So gave us 2 lines of space. And now it's waiting, because that program is just sitting there now waiting for us to hit a key before it can exit. So in other words, it's hung up waiting for some kind of input. So now that it's saved, I can also then look at it here inside this folder. And if I run it, notice now it ran that program and it stayed up there because it's waiting for us to do something. So now I hit enter, and then it actually closed down that text window. So without doing anything else, this is the easiest language to be able to start things. So I could print William. And one of the things we love about any of these languages is the ability to cut and paste. So if I wanted to print William 10 times, or 15, or however many I get here. So I have to save this before I run it. And so I can either run it from here. Notice it printed out all my lines of William very, very quickly. And it's waiting very patiently for me to exit. And we're out. And that is the nutshell of Chapter 1. And that will give you everything you need to know to do the assignment for Chapter 7. So there's 4 questions. One of them requires you to write some code. You need to write that code then inside of our Python environment. So let me show you how to open that up again. File, New. When I click New, so inside of the shell we have a piece, and it opens up kind of a text editing window for us to begin to work on. So notice I can do the print commands, and I can go in and I can save these files. So you need to make sure you can save it. You need to make sure that what it looks like, so in our case here, it looks like a name. If I do properties, for example, it will tell me that it is a Python file, a .py. So here's a question. Do I have to use this particular environment to write Python? Can I write Python in a text editor? And it's not necessarily as critical for us in Windows because we have this editor. But if I wanted to create the very same thing, I could do the same thing in Notepad because all we are doing is creating a text file. I do have something a little tricky though. So in Notepad, which is a very handy program, every computer has Notepad, so I could write it on any computer whether it's even got Python installed. When I click Save As, it's not going to automatically save these as a Python file. We have to select all files, and we'd have to put in here, so we could put in program.py. So we have to manually put in that it's a Python file. But these two pieces give us everything we need for this particular class. All right, any questions on that so far? Caleb? Okay. Pretty straightforward. So then we start looking at Chapter 2, and Chapter 2 then talks about variables, and again we're looking at input and output. And we started an input program where we inputted something just to wait for our input to keep a program to running. So on page 16 and 17, we have what's called a useless trivial program. And so that useless trivial program, though, demonstrates a couple of things that we're going to work on. So on page 17, there's some code. And so I encourage you to type in this code so you can see how it works. So one of the things we need to make sure we are aware of is, so we're going to start a new program. So I'm going to close that out. Nope, don't care about it. I'm going to start a new file. Is how do I do comments in Python? And so some languages use slashes, some use other notation. In Python, we use our friend that £. And so anything in this £, says it's going to be a comment. So this is a sample program for cmis210. And so anything I put in £, then tells us that it's not going to actually run in the program, but it may be important for us. A couple of different things on these print statements as you go through there. Notice I can type print, and they have same And we can actually have multiple items in a single print statement. And in fact, what's kind of interesting, notice I didn't close that, and that's one of the common things you might do, is not close your parentheses. So once I close that, life is all better, and I can then actually even run this program. So run it. Yes, we're going to save it. We're going to call it, we're just going to overwrite. Yes. And so notice it says same message as before. Even though we separated them, it puts them all on the same line. So what would happen if I have another print statement behind that or below it? And so I'm curious where this text is going to end up. So is it going to automatically be on a new line? Is it going to be appended to the other text we have? And in fact, one of the interesting things I want to point out with this previous line, notice by putting a comma in there, it did actually put a line space between each one. So let's run this now. Of course, when I run it, it's going to say, do you want to save it? Yes. So some languages are different than others. There are some languages where we explicitly have to give it a line return to say this is going to be on a new line. In Python, we don't necessarily have to do that. And in fact, it handles text very, very well. So in most languages, these would all be concatenated together. In other words, there'd be no space between those. And so we would have to put a space inside of the parentheses. And so that's just a common quirk, something different that happens with this language versus quite a few others. So. Page 18 talks about a quote within a quote. So how do I print out on screen? We use quote marks to tell our computer that it's text and that it's a string. So how do I get text then that includes that quote mark? And so that's a little tougher. And so make sure you've read on page 18 how to do that. Page 19 talks about multiple values and a final string to print. How do we get that to work? So there's some ability. And then finally, page 20 talks about something called triple quoted. So make sure you use and look at those. Page 21 looks at something called ASCII art. And again, that's something that's fallen by the wayside now that graphics are so easy to use, but it's kind of an interesting old school approach. So page 22 looks at a tab stop. And then one of the most important things on page 23, and we already introduced you to it just briefly, is that idea of a new line. So, how do we do a new line? And that's simply that /n in our quote string. There's a couple of other special characters. So one of them, so if we're going to write a game, we may want to get somebody's attention. And /a actually rings the system bell or sends a character in that says, let's create some sound. So page 24 and 25 start talking about more items. You'll see the term concatenating. So we put two strings of text together. So concatenating simply means we have the idea, I have to close that. And notice it does a little bit of color coding in there for us. So concatenating simply means we put two text strings and we can actually shove them together. So our examples may be a little bit silly. But it's a useful skill. And then Python also does some kind of interesting things. So if I want to print the same thing multiple times, so maybe I want William again, and I want to print William 20 times. Well, there's a shortcut, and we'll show you what it looks like. I can simply type William in quotes times and 20, and when I run this, yes, I do want to save it. Notice it puts William 20 times, but also notice how it did that. Did it put any space in between them? No. Did it put a new line on each one? So, but it can be useful for us as we start working with these. So Python works very well with numbers and letters very easily. On page 28 in your textbook, we start looking about the idea of numbers and types. So in our pseudocode, we really just said we have a number, or we have a string, or we might have called it text, and we didn't have to worry about anything else. Well, Python gives us the ability to use several types of numbers, and some of it depends on the amount of storage we need for each number. So the smallest storage we're going to use is something called an integer. So integers don't have fractions. So if I think about it, an integer is just a whole number. So if I'm creating a loop to count to 1 to 10, an integer is a great way to count from 1 to 10. If I'm creating a program that's going to divide, when I divide, I almost always end up with some kind of fraction. And when I have fractions, I need to use something called a floating point number. So in other words, I have two types. I have that integer. So 1, 2, 3, 4, those are all examples of integers. Floats then anything with a number or a decimal. Now, can this be a float? Can a number without a decimal fraction be a float? Sure, because we're still representing it as that idea of it being a decimal fraction. So anytime we're going to work with numbers, so unless we're going to work with only integers and we know that it's going to return an integer, so we might have an issue. So a lot of the times we use integers for those very simple countings, and we use floats then when we start manipulating. And so on the bottom of page 29, there's a table that shows us a couple of different numbers. So, or operations. So, plus, minus, those are all pretty common. We understand those. We know how to do the multiplication, and we use the asterisk for that. And then notice we have two different types of divisions. And so we label them with a single division mark. So this is what we call a division or true division, and it returns a decimal fraction. So if I divided 10 by 3, and that should give us 3.3333, however many times we want to repeat that. On the other hand, if I use, so 10 divided by 3 is going to give us an integer result of 3. So there might be some occasions that's kind of useful So if we want to know how many times around a racetrack a car has to get to 200 miles, then that racetrack is 1.9 miles or something. This might be useful because it'll give us that round number that we're used to. The other operator that you haven't seen before probably is this operator called the modulus. So what is a modulus? You guys remember from math class what a modulus is? Michael's looking at me like, what the hell? So if I divide a number, so I divide 7 by 2, what do I get? What's 7 divided by 2? So it's 3, and if we called it a remainder of 1, right? Remember when we divided by hand, you could have you divided 7 by 3, you had a remainder of 1, and then you divided again to get that decimal fraction piece. Well, the modulus is another name for that remainder. So sometimes we want, so if we put those two pieces together, we get an integer and that piece that's left over, and it's kind of handy occasionally. I know that seems weird, but occasionally that is kind of a handy thing to utilize. So most of the time we're going to use those first 4 operations. You're going to use a real division, and you're not going to have to worry about an integer division or the modulus. But what this does, and in a lot of other languages, to get that result, we had to do all kinds of strange things. So I would divide 7 by 2, and I really wanted an integer, so we know it's going to equal 3 dot blah, 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 whatever that is. And so I would have to then do some other mathematical operations to separate that out, whereas Python gives it to us pretty quickly. So it gives us a quick way to work with values. So most of the time, let me delete some of this, just make life a little easier for us. Most of the time, variables are pretty easy for us to utilize. So if I wanted to just put in a variable, and there's my obsession with William again kicking in. So name equals William. So that equals becomes that assignment operator. And so let me take out this and this. Okay, so name equals William. And so then I can, instead of passing in into a print statement, print, instead of passing in William, I could pass in that variable name. So I could just put in name. And so now when I run this, run module, yes, notice it prints out William, and I called and I passed in that variable name. It just gives me a quick way to do things. I can combine them just like I could with other print statements. So print hi and separated with a comma, name, and that will print out, hopefully. Notice it says hi William, so it can combine a text string and a variable in the same line. So we can use those variables pretty easily. And notice I got to cheat there a little bit. Did I have to explicitly say that variable was a text or a string? No. Python's pretty good about doing that. So one of the things we need to do then, and you might want to look on page 32 for some of these rules, is we can use variable names of anything we want. We need to make sure that they're useful and they're not something that are going to cause us issues later. So name seems pretty descriptive. If I just said A equals something, A doesn't tell us anything. So we want descriptive and self-describing names. Okay. One thing we might want to do is use names that are very descriptive and have more than one word. So we might say high score equals a value. Is there anything wrong with that? Can I have a space in my name? If I have a space, when it parses or reads this language, it doesn't know that that's all one variable. So I have two choices. I could put them together, and I separate the words with capital letters. That's one method. The other method is I separate them with underscores. Those are the two most common methods you want to use. What I will encourage you is I don't care which you want to do, create these descriptive names, but I encourage you to be consistent. So if I use the underscore, I don't want to see a mix of those. I want to see all underscores to separate your descriptive names, or all concatenated together. So just be consistent within yourself. There's a couple of other things we want to do to make sure we're fairly consistent. Normally, so variable names tend to start with lowercase. So here, it's just kind of a convention. Is there anything wrong with starting it with a capital H? Will it work? Yes. Will it drive us crazy? Occasionally. So I tend to like to concatenate together with a capital letter to separate the two of them. We can use variable names up to 255 characters. So I said descriptive is great. 255 characters gets kind of unwieldy. So try to be descriptive and yet not so overbearing in length that it becomes an issue. So variables are something we're going to use quite often. I'll flip my page here. Okay. So variable names, wonderful and great. So now, how do I get values into my system? And so we talk about user input, and we can actually combine a couple of these together. So traditionally, in a lot of languages, I would have to say name equals, let's delete this real quick, name equals a variable name, but I can cheat a little bit, and I can put the value in on the input statement and declare it right in the same line. So I can say name equals input. So notice I'm putting a function then. What is your name? And so this will actually allow me then to run this program. So let me run. Yes. Okay. Go backwards. Okay. Now, I said white space is normally free. Sometimes indenting causes some issues. So it's asking me for what is your name? So I put in, now I've got some other stuff in there, so you're going to see it mess up there a little bit. And notice here is the one time I need to put that space in there. So now if I run it, what is my name? and it assigns that value for input. So user input is something pretty commonly done. So the input function, so again, it's a function. We input data with it. So there are a lot of string manipulations that we can do then. So page 35, 36, 37 start talking about the idea of string manipulation. So string manipulation, we can do things like uppercase, lowercase, titles. And so there's an example of that, so make sure you work your way through those. So on page 38 is a chart. And so it might not be a bad idea to kind of highlight these charts, put in a sticky note. So useful string methods, upper, lower. So you can swap a case. So each letter is flipped. If it was uppercase, it's lowercase. You can capitalize. You can take out spaces, which is kind of interesting. And we can actually replace pieces inside a string quote. So in other words, you can do a direct replacement right from the programming language. So right now, so far, we've looked at 3 different data types. So you've got a string, you've looked at integers, and we looked at floats. And so on page 39, we start looking at what can we do with those. And so there's a program called the Trust Fund Buddy program. You can download this, however, not from the course location that they list here, but if you go into course documents, I've got it up there. So, and that Trust Fund Buddy actually shows you a logical error. And so what we think and what we're doing are sometimes different. So, one of the things that we often do is we take in data and an input, and we take it in as a string, so we don't care what they bring in, and then we convert it then to a numeric value. So why would we ever want to do that? What if we think we're going to get in a number and they put in ABC? Is that going to cause us an issue? But if we take it in as a string, then we can evaluate it, convert it to a number, and hopefully eliminate any kinds of those issues. So on page 41, we start talking about that ability to convert strings to integers or strings to floats. And so on page 43, there are the conversion functions that we're going to use. So that is a very, very common thing that we do, is we convert from strings into some kind of a numeric value, and it allows us the user to input any value and doesn't cause us a program issue if we do that. So we can then build a loop, which we haven't quite got to, where it would say, oh, this doesn't match the criteria. There's some assignment operators on page 44, some shortcuts. So if I want to take x times 5, so we write it as something like x equals x times 5, and we can actually shortcut it in these assignment operators. There is nothing that says we have to use any of those. It's just a way to write it a little shorter. So it's just a simple way to change something. Well, why would we ever write these? So we have a couple of things we want to do here. So now we looked at variables, and the only way is to actually get your hands in here and play with them. But let's look at one just to see what happens. So we want to do something. So we want to say age equals, we'll call you 32 years old. And I'm going to have a variable called seconds equals age times. So how would I convert that into seconds then? How many seconds are there in a year? Do you know? So how would I start converting that? So we know age times a year. So how many seconds are there in a year? How many hours are there in a day? How many seconds are in a minute? So there's 60 in a minute, and there's 60 minutes in an hour, and there's 24 hours in a day, and 365 days in a year. So if I run this, yes. So why did that not calculate and print that out for me? Am I missing something? Oh, and that again is that common logical error. So print, and so I'm going to print seconds. Okay, so now I can run module. Oh, so what happened there? I got an error message, and it gives me some information, and it says, oh, file, here's my program, line 9. Okay, so up here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I didn't get the variable names correct. That happens far more than you would imagine. So, at 32 years old, you have a huge number of seconds in your life. Now, the other thing I encourage you to put on at every program is an input. And I just get in the habit of putting this in my template file. Something like this, press the enter key to exit. And I know that seems silly because over here, it doesn't do anything. It'll actually run. But let me run this program for you directly. Notice how it flipped up and died. It's gone. So in order to be able to keep that program visible, I need to put that input statement in there. So I'm going to save it. And now if I run it from inside there, now it actually runs inside my terminal window and it stays visible the entire time. So there's a couple of pieces this week. So make sure you've completed Chapter 7. Chapter 7 should be pretty easy at this point. And then Chapter 8, or Week 8, I keep calling it Chapter. So assignment, Week 8. So now you need to write a program that lets us work with strings, numbers, convert between the two. So you have to work your way through this chapter. Try out all these new things. There is a discussion board this week. So make sure you take that discussion board. And that Chapter 8, you're looking at Why did we choose Python? Are there other languages we should have or could have or would have or maybe we could have chosen? And then if I look at my schedule, and almost the quickest way is to click on assignments, notice something interesting. So we go from week 9, ends on 3/23. So next week, remember we're having spring term break. So I'd like everybody caught up. I'll catch all the grading up. So we'll start on a clean slate then after we get back from spring break. Don't forget what we're doing. Go back in and look at the book occasionally. But once you get your hands dirty in this, I think you're going to find it more fun than writing the pseudocode. The frustrating part is those silly little syntax errors. So forgetting a quote mark, forgetting a closing parenthesis. Those are the parts that are going to probably be the worst. So if you have questions, I had several people turn in assignments and they had questions inside the assignment. I couldn't get this to work. Why did this not work? Ask those ahead of time, please. Because once you've already turned it in and it's past the due date, it's a little later. And if there's several students missing the same type of items, I can send out an announcement, a quick video, something like that to try to assist you as easily as possible.